In this video, we're going to look at examples where we have the special right triangle of a 30, 60, 90 triangle. Remember that the relationship between our side lengths are that if we say our shorter leg has a length of S, the longer leg would have a length of S times the square root of 3, and the hypotenuse would have a length of 2s. Now this is a little bit trickier than with the 45, 45, 90 triangle because we have to determine which is the shorter leg, which is the longer leg. Remember, in a triangle, the shortest side is always opposite the smallest angle. And in a right triangle, the longest side is always opposite the right angle. So we just need to decide which angle is the 30 degree, which angle is the 60 degree. Again, emphasize, it has to be a 30, 60, 90 triangle for this ratio to hold. It's not true for right triangles in general. So in this particular triangle, I do have a right angle, that's my 90 degree. These two angles then must have a sum of 90 degrees for the total to be 180 degrees. So if this one's 30 degrees, 90 degrees minus 30 degrees would make this angle 60 degrees. So I do have my 30, 60, 90 relationship. So which side do I know? Well, here's my smallest angle, the 30 degree angle. So the opposite side is the shortest side. That would be the shorter of the two legs. So in our ratio, that represents our value of S. So now the longer leg is Y. So Y would be S times the square root of 3. And so in this case, if S is 13 inches, then Y is going to be 13 times the square root of 3 inches. Z is taking the place of our hypotenuse, and in our ratio, the hypotenuse is 2 times S. Since S is 13 inches, Z would be 2 times 13 inches, making Z 26 inches. Now that example, we knew the shorter of the two legs. In the next two examples, we do not know that. Whenever the shorter leg is not known, that's the thing we need to find first, because everything is based upon that shorter leg. See how there's S in all three of those. So, in my second example for the 30, 60, 90 triangle, again, I have a right angle, that's the 90 degree angle. Here I have a 60 degree angle, so this angle would be 90 minus 60 degrees. So I do have my 30, 60, 90 relationship. So the sides are in the ratio of S to S times the square root of 3 to 2S. In this particular case, V is my shorter leg. It's opposite the 30 degree angle, but I don't know that length. Which side do I know? I know the hypotenuse. So I know that the shorter leg times the square root, let me back up, sorry about that folks, that the shorter leg times 2 gives me the hypotenuse. So in this case, 2 times S is 24 yards. If I divide both sides of that by 2, now I know my shorter leg would be 12 yards in length. And so because V is the shorter leg, V is equal to S, so V would equal a length of 12 yards. U, being opposite the 60-degree angle, is the longer of the two legs. Remember, this isn't a leg, it's the hypotenuse. The longer of the two legs. So U is going to equal S times the square root of 3. We determined that S was 12 yards. So U is going to be 12 times the square root of 3 yards. Notice how when I did not know the shorter leg, that's the one I found first, because that's the one that all the others are based upon. Okay, last example here, we have this right triangle. We have the 30-degree angle, the 90-degree angle, so that leaves this angle to be 60 degrees. We have the relationship that the sides are in the ratio of S to S times the square root of 3 to 2S, going from shorter leg to longer leg to hypotenuse. So in this case, let's see, 30 degrees, K is the shorter leg, so I don't know that. That's the one I want to find first, however. See, J is the hypotenuse, so that means the 12 meters opposite the 60-degree angle is the longer leg. That fits into this one in our ratio. So that means we know that S times the square root of 3 is equal to 12 meters. So to solve for S, we would divide both sides by the square root of 3. Now, if you remember in the 45-90 video, we rationalized the denominator. That means we brought the number out of the square root. We can do that by multiplying the fraction by the same thing in both the numerator and denominator, because that essentially is multiplying by 1. So in the numerator, we're going to have 12 times the square root of 3. In the denominator, square root of 3 times the square root of 3 is just 3. In this case, now the numbers, their factors outside the square root can be reduced, and so we'd find that S is equal to 4 times the square root of 3 meters. So, if I look up here, K is our shorter leg. So we now know that K is equal to 4 times the square root of 3 meters. What's missing? The hypotenuse. The hypotenuse is this number in our ratio. So we know that J is equal to 2 times S. We found that S was 4 times the square root of 3. So we're going to have J equaling 2 times 4 times the square root of 3 meters. And so 2 times 4 is 8. So we have 8 times the square root of 3 meters as our value for J. Remember, these ratios are only true in these special right triangles. If it's just a right triangle in general without the 30-60-90 or 45-45-90, we're not able to do these special things. In those cases, we have to know two sides, use the Pythagorean equation to find the third side. It's only in the cases where our acute angles are 45 and 45 or 30 and 60 that we have these special ratios.